Hello, my name is John Capobianco, and today I'm going to be building on my previous work with fine-tuning. Now, I had written a few blog posts that we're going to explore, and ultimately I had mixed results with my inference, my testing of the model that I created and fine-tuned. We'll get into all this later. I'm just setting the stage. And it also took an extremely long period of time to fine-tune the model in a GPU on quite a high-end computer with an L4 card, NVIDIA card, and lots of resources. I'm talking about 40 plus hours, 2 days in the GPU fine-tuning with some of the most modern approaches that I could find. A colleague of mine at Cisco, this was a few weeks ago. I'd been busy with Cisco Live and some other side projects of my own and work and family, sent me a link to a paper that I'm going to show you and a GitHub repository I'm going to show you from Stanford, which I believe has democratized fine-tuning and made it accessible both in terms of the code and the implementation, as well as the output and the inference responses, and finally, the time and hardware constraints. I'm talking about fine-tuning models in minutes down from, tens of hours. And to be fair, let's say tens of minutes to an hour. Now, this is also on a much less powerful, but still capable and high-end gaming system. And I owe Dave Sachs a lot of credit for giving me access to this sandbox, but also for collaborating and helping me develop and ideate and think of the realm of the possible with the fine-tuning. Now, before we get into this, I had success and I used the exact same data set intentionally so that I could give you a comparative, subjective view of the previous approaches that I was using to fine-tune and this new approach that I've found. I will be giving credit where it's due in the code. Speaking of the code, I truly believe in democratization and universal access to all things related to AI, but in particular, letting people create their own models from their own data sets, privately, locally, for free. Now, by data sets, to give you an example, I found a Cisco validated design, which is a PDF. Everyone has PDFs. That's the particular PDF that I used. And within that PDF, there was a table of VLANs, their VLAN ID, their name, their purpose, their subnet, their IP address, a gateway, and use that to build a data set that then I use to fine-tune the model. And this is known as ReFT, Retrieval Augmented Fine-Tuning, where we combine RAG with fine-tuning, Retrieval Augmented Generation, meaning get the data from the PDF to generate the questions and then use that data set to fine-tune. This is kind of a similar approach. I've decided intentionally to just use the large context window because it's big enough in my purposes. I could plug in true RAG with a vector store, which I may do. But for now, let's get into ReFT, Representational Fine-Tuning, this new approach. And this is going to be a long-form video. There's a lot to explore here. I am going to make cuts because certain aspects of this do take time, and I don't want this to be like a 3-hour video. So thanks for sticking with me so far. This is very exciting. And think in the back of your head, PDFs, or specifically in this video, we're going to be fine-tuning a model, the Llama 3 model, with the show running config output from the Cisco DevNet Always-On Sandbox. So this is Cisco iOS XE in the cloud, publicly. It's not Cisco internal data. It's not customer data. It is ephemeral, public sandbox data. We're going to get that running config. We're going to turn it into a data set, questions and answers about that running config, and then fine-tune Llama 3. We're going to test it with inference against those exact questions, and then we're going to publish this to Hugging Face. The next steps are to download the model from Hugging Face in a completely fresh environment and see if we can do inference testing outside of the exact same questions. So keep this in mind, network engineers, network designers, people involved with logs or running configs or state or configuration. We'll get into all of that. So that's my hook to stay tuned, that we're going to start fine-tuning models that then do not need RAG or Raptor. They know it's a closed book exam, and we've given it all of the answers based on our configurations. All right, let's check this out. Okay, like I said, I had written 2 blogs about ReFT and fine-tuning, augmenting network engineering with ReFT. And in this first example, I break it all down, and I actually use the cloud service to fine-tune the model. So I started with OpenAI's fine-tuning in the cloud as a platform. I had some failures. I adjusted my data set. You have all the statistics, and it costs you some money, and you can actually access it through Postman and access it through API calls. It's all broken down here. I then tried to recreate that locally, using some open source approaches and some code I found using LoRa and Orpo Trainer. And I did the RAG piece. Here's that VLAN table. This is all broken down here. Okay, so recently, this was sent to me, ReFT, Representational Fine-Tuning of Language Models. And, here's credit where it's due. And I'll show you where else you can get more information. But it's funny because, why is it different? So it's weightless. And this has a notion of time, whereas PEFs lack the notion of time and update representations across all layers and positions. So you can read about this later. But I thought this was neat that they did not expect it to perform well. And I can't believe how well it performs. We're going to see that today. So the paper's here on the Stanford EDU, and I encourage you to take a look. Here is the GitHub repository where it gets interesting, right? So they have PyReFT, and it explains all of it, and you can actually make this little chat bot where it answers with emojis. So a 30-second guide, and I followed this guide, and it's actually kind of neat. Let me show you some things here that I found interesting. So number 1 in the data set, it looks like it's just the question and the positive answer. Previous straight data sets, we had to have the question, the correct answer, and an incorrect answer in the training data set. Here, they just have a bunch of random things, and they force the answers to be emojis. So if you go further, right, it takes no time to train, and they show you the loss and everything here, and I'll show you this and attest to this. And the other thing is, here is the inference testing. Which breed of dog, which dog breed do people think is cuter, poodle or doodle? And it actually answers with emojis, right, in the inference testing. They even go on to show you how you can share your fine-tuned models on Hugging Face. And I'll show you how that's done. And then later, which I have to do next, is load the model locally after I download it, after it's been uploaded, and then try this inference testing against the model that I've downloaded. So tools that I'm using and what my approach is. The first thing I need is a DevNet sandbox. So we go to the developer.cisco.com/site/sandbox and we launch a sandbox. This is not necessary if you've open sourced, if you're using my code. I'm just showing you where this is, what I'm using. So I'm logging in with my GitHub, and Now we can search for iOS XE once it loads everything. And we can see that there's an always-on version here and the instructions and the credentials. So I've turned this into a PyATS testbed. So what is PyATS? Well, I just released a book on Cisco PyATS, if you want to know more. But it's a framework from Cisco that allows us to Pythonically interact with networks and write tests and automated solutions. So I'm using that framework to interact with these credentials in this sandbox in the form of a test bed. So this test bed's all you need to connect with and start interacting with the router in the cloud. Okay? So the other things I'm using are Ollama, which you can just download for Linux or Windows or Mac and start using open source models like Llama3, which is the model that we'll be using today. Now, how am I using this model? This model is being used in two ways. First, I'm using it to evaluate the running config that PyATS is going to return to us and generate 1,000 questions and answers, correct answers, using that actual running config to source the answer with a prompt. So Ollama is first, or Llama3 is running on Ollama, and it's first being used to generate the data set that then we are going to use to fine-tune Llama3 and make our own model that we're going to open source on Hugging Face. Okay, so we're using Llama on the front end of this process and at the back end as the model we want to use as our base model to fine-tune. Now, I'm going to be using Hugging Face here, and if we go into my repository, you can see I do not have any models. I've cleaned out my models. We're going to start again. I'm also using wandb, which you're going to see its purpose in a second. Once we run this, it's going to collect the telemetry and the observability and the statistics about my fine-tuning job. And I have a 30-day trial for now, but you can see that I have a couple of projects here. I'll save that for later. So let's get a model in here trained from Cisco IOS XE DevNet Sandbox in the cloud. I'm inside of a Windows computer with WSL Ubuntu. Now to install this on your own computer, you launch PowerShell in admin mode and do WSL --install. It will actually install Ubuntu now. And in my terminal inside of VS Code, Visual Studio Code, I am inside of a virtual environment. Now to create one of these, you would do Python 3-m venb, name of your venb. Then you would do source, name of venb /bin/activate. Once you're inside of here, you need to install the packages inside of the requirements. So the request library, PyATS full, and the Stanford PyRef installation. This can be done with pip install -r requirements. Okay? So we're going to go inside of the Cisco folder. And before we get started, let's take a look at some code. So I've attributed, cited the citations. We're going to run a PyATS job. Now this is the job file, and it's going to load that testbed file and run this Python script. It's going to take care of and abstract the loading of PyATS, the logging, the mechanisms, everything you need for PyATS, and run this script that has a common setup, a common test execution section, and a common cleanup. In the setup, we connect to the device in the test bed, and we run in a loop in case there's more than one devices, the show run test. This will do device.execute show run and save the show run output. That's pretty much for PyATS all its function is here. We're then going to go move on and load that file and use Llama locally to generate questions and answers based on this prompt. This prompt can be adjusted in your code, but it more or less is going to look at the show running config and append the show running config to the end of the prompt and ask it to generate a series of questions and answers. All right, now I'm going to minimize these functions as we go to cover them. Now let's go ahead and start running the code, and I'm going to explain why this question and answer generation takes a bit of time. So now that I'm in here, I can say Python fine-tune model. The only thing I've done additionally is exported my Hugging Face token and my wandb token as environment variables. So that way we can use Hugging Face and wandb in this code. Okay, so with a slight adjustment, it's actually running the PyATS job now. And there's the show running config that we're dumping out to a file. And you can see the show run here. But now we're going to start to generate, and I've made a very small data set for the purposes of this video of just 25 question and answers. We're going to scale that up to 100. So it's actually trying to do that now. Now, more often than not, or sometimes, the Llama3 will answer with Q and then question and then answer and the answer. So it's actually appended. Now I have to try this because I'm not always going to get the same answer, but I've generated these 25 questions and answers from the running config. So let's just check one real quick. What's the IP address of loopback 0? 10.0.0.1. 10.0.0.1/24. So we're going to take these, and now you can actually see we're fine-tuning the model. Okay? So it's actually fine-tuning the model. We can actually look at wandb's interface here and see the statistics of the model training as well as the hardware. So eventually there will be more panels here as we get more data coming from this job, but we will be able to see the hardware implications as well. So now I'm testing the inference of these questions in a generated answers spreadsheet. So if I show you the spreadsheet and we see what is the IP address of loopback 0, the IP address is 10.0.0.1. So the inference is working. Now I'd like to ask it more generalized questions. How many interfaces do I have? What IP addresses are in use? That kind of thing. Now I've output the model to this local directory. And if I go into Hugging Face now, let's see what happened here. Client repository not found. So I had an error. Okay, so I'm just going to start again from this point because we had a little hiccup. Now, what I want to highlight is just to test all of this code, which we'll go through while it runs. I'm going to limit the amount of questions in the data set. So let me just clean up and start from scratch here. We had a little hiccup. What I'm going to do is limit the number of questions in this to 25. Now, when I'm ready and positive that this code works from end to end, I'm going to adjust this to 1,000 to scale it up. But for now, we're going to do 25, and I'm actually using 10 iterations. Should be a value of 10 here. So I'm going to loop through my AI generation of text a maximum of 10 times or until we reach 25 questions. Okay? Again, just to prove Now, when the time comes, I will scale this up to 500 loops, and we will scale the number of question and answers to 1,000. But for now, and just to show you, I do not have any models in Hugging Face, and locally I don't have any model folders or anything like that. So we're going to run the fine-tune model. I've logged into Hugging Face, and in my code I have a txt file that I'm ignoring, that at the very top of my code now, I'm logging into Hugging Face by loading the key from that file. All right, so the PyATS job has completed, and we can see the show run. This is right from the top of the logs. We have the successful Hugging Face login. The PyATS code runs, and we get the show run. And now I'm looping through my AI generation of question and answers. Now, why you might see no formatted output generated, I found that more often than not, or through my prompt, I'm trying to force it to do a question and answer as two different lines, like Q and then A. And every time it successfully does that, I am then able to Pythonically extract the question and the answer. But it's not perfect because it's AI and the response we get back varies. But I have reached my 25 questions here in the output. Now to prove it, if we look at loopback 0 and 0001 in the show run, if we look for loopback 0, that is the correct IP. So my RAG is working, and my output, these 25 questions, or 30 questions, however many we have here, are now part of a data set. So if we go back to the code, right, let me minimize this a little bit. And what's happening now is the GPU is pinned as we're fine-tuning the model. That's what's happening right now. And there are checkpoints and different information that we can look in the wandb, and we'll look at the report at the end of the job. But back to the code, we have done our prompt generation. Let me start minimizing these from the top. We've saved that to the CSV. We've, cut it off at 250 or 25 entries in this case. We're loading the training examples. We're forming those QA pairs. So it's question, comma, answer. And then we're generating the data set. So this is the one that actually runs the PyATS and loops 10 times to invoke some of those earlier functions to create the output file. We call that, and then we load up the training examples. Our output file is generated answers, which as you can see is done now. I'll explain that in a second. But from everything here down, we are fine-tuning the model. So with this prompt, you are an AI expert specialized in iOS XE running configurations. Your role is to provide accurate, clear, and concise explanations or solutions directly relevant to the configurations and queries presented. Ensure your responses reflect deep knowledge and practical applicability. Okay, so that plus our question and answers are going to fine-tune the Llama 3 model using the GPU and CUDA, as you've seen. And the rest of this code is commented. So we're going to load a tokenizer to tokenize it. We're going to pad that token. We're going to set up the ReFT configuration from the GitHub repository from Stanford and follow their code to create a data module, to define the training arguments. You can see they use 100 epochs here with a 4E3 learning rate and 20 logging steps with a batch size of 10. all of which are adjustable and even more tunable if we want to change these values. We're going to train the model, and then we're going to load our questions and do inference and write our output from the questions. Now, finally, we save it into Hugging Face. Now, before we go too fast and too far, let's go back a step. I've taken these 30 question and answer pairs. What is the banner message displayed when a user logs into the device? This is my banner for all of my device. If we look in the show run and look for banner, you can see that is the banner. So we've used this as a data set that then we have trained the model, which is in this folder now, which has a config.json file and the model file itself. My answer inference to test the exact same questions. Now, I haven't tested it with abstracted original, what can you tell me about this configuration type questions. I've actually tested the exact same questions to make sure that loopback 0 is 10, 10, 0, 0, 1. Now, all of these answers are correct and have been fine-tuned into the model. So if we hop onto Hugging Face and refresh models, we have this model. Now we can create a model card, which is what I'm going to do pretty soon. I thought there was a wizard to do this directly on the website. Import model card template. I'll have to look into this. The last time I did this, the model card had a predefined template. So anyway, we'll get back to that. Now, if we look in the wandb, let's check this project on wandb. And this is weights and biases.ai, W&B AI, and it's tied into my Hugging Face account. And you can see things like the grad norm, the epochs, all the way up to 100, the global step rate, the training loss, and you can see some of the loss curve here, the learning rate, as well as the actual hardware observability. So things like GPU power usage, memory allocated, time spent accessing memory, power usage in watts, even things like the temperature and GPU and, a whole bunch of dashboards here giving us deep insight, system CPU utilization per core. And we can see all of this great metrics. So now, I guess the next step is going to be to clone this repository and bring it locally and then test inference against it. Before I do that, because our test run worked, I'm going to clear, and what we're going to do is adjust those settings back. So we're looking for 1,000 here. So once the queries reach 1,000 and our loop was 10, which we want to make 500 here, let's go ahead and flush everything out, our answers, our output, our show run, delete this, and start this again. Now, garbage in, garbage out. I highly recommend that you take a look with human eyes and make sure that the answers are correct. Do some spot checking. Find a way to maybe use AI to confirm it with RAG. Here's the running config. Here's my question and answers. Are they all correct? Before you commit to the model. Also, this is going to take some time. So I'm going to need to stop the video because it's going to take a while. It's starting now to generate 1,000 question and answer pairs. And 2, it's going to take about an hour in the GPU to fine tune from a data set that's that large. So I'll be back very soon with the output and a new model. Stay tuned.